So what we're going to do in part 2 of this lesson is talk about how condition variables can be applied in practice, and I'll talk about a human known use. We may or may not have time to talk about this in its full-blown glory, but it's a cool example. So condition variables are very powerful, but they're also a bit hard to understand and they're a bit hard to apply correctly. And so for that reason, we typically apply them, we typically hide them. And why they're complex is because they have all these moving parts. And here's a sequence diagram that illustrates two threads accessing a condition variable in the context of a monitor object. I won't walk through all this stuff in detail right now. We'll go through it later. But the point is there's a lot of things going on there. In this case, we have a monitor object and a monitor condition. And we end up with non-determinism, which is tricky because things are always occurring in strange orders that are hard to reason about with our relatively sequential brains, right? It's very hard to reason about concurrency and parallelism because our brains are sort of sequential inherently, at least the way we think about stuff. One of the consequences of this is we typically need to use loops. So you're almost always going to be checking the condition, see if this condition is satisfied, and waiting if it's not in a loop. So as a consequence of this, we almost always use condition objects within a higher level abstraction. Some other higher level abstraction hides the condition object for us. A good example would be the array blocking queue we talked about in the reentrant lock example, which we'll come back to and revisit next time. So you very rarely use condition objects directly. You almost always hide them behind other things. And therefore, they're used appropriately. Let me put it that way. They're used appropriately within Java's class libraries as part of the implementation to make them work efficiently and correctly. In particular, all the blocking queues that we're talking about use condition objects. The decks, the concurrent decks, also use condition objects. So array blocking queue, linked blocking queue, all these other kinds of things use them. Java built-in monitor objects, which we'll talk more about probably starting next week, also use condition. They use condition variables, not condition objects, because a little bit hard to understand this distinction, but Java built-in monitor objects are implemented at a lower level than the condition objects. So built-in monitor objects, as the name implies, are built into the Java language. So it's implemented as part of the virtual machine or the execution environment. Condition object is a class that's implemented largely in Java, and it exists in a different layer in the space. The monitor object pattern is really the broader abstraction of which built-in monitor objects are one realization. We'll talk more about the monitor object pattern later. And let me finish off with the human known use. So this is a good way to remember condition variables. Remember when we talked about reentrant locks? We talked about the restroom protocol on an airplane. So that kind of sticks in your head, right? This example is a little bit more complicated, but it's still kind of fun. So we're going to use pizza delivery as the metaphor, as the analogy. So let's say, for sake of argument, that you want to make some extra money while you're at school, and so you're going to deliver pizzas, because pizzas seem to be sort of recession-proof. When times are good, people order pizza. When times are bad, people order pizza. So everybody always wants pizza. And the way this is going to work is you and a bunch of your friends are going to go work down at the pizza parlor, let's say, Papa John's or Domino's or Jets or whatever. And because this is like a second job, because you're a full-time student, let's say, maybe it's a third job, depending on what else you're doing, when you're not actually delivering pizzas, you're just going to rest. You're going to sleep. And the way it's going to work is, let's say, again, for some odd reason, that you have 5 people who are pizza delivery people, but only 1 or 2 trucks to take the pizzas around. And so the way this is going to work is the cook or cooks will be cooking the pizzas. When a pizza's ready, the cook puts the next pizza on the pickup counter and rings a bell. So that's a signal. And that's going to cause all the pizza delivery people to wake up, and they're all going to try to go grab the keys to the truck, because whoever gets it gets to make the delivery, gets to make the tip, right? So the protocol is there's keys, there's a pizza, there's a bunch of pizza delivery people. When a pizza's there, ding, the bell goes off, everybody wakes up, they try to grab the pizza, and they try to grab the keys. And it's important that they do it in that order, by the way. And likewise, when someone comes back from a delivery, they put the keys back on a ring, and they ring the bell. So you get signaled when either there's keys available or there's pizzas available. In all cases, everybody wakes up and tries to grab the pizza followed by the keys. Why is it important that they all try to grab them in the same order? Right. And what would happen if that was to occur? Deadlock, exactly. You don't want deadlock. So if somebody grabbed the pizza and someone else grabbed the keys and they wouldn't give up either thing, no pizzas would be delivered, right? So you try to grab the pizza. If you grab the pizza, then you try to grab the keys. But if the keys are gone, you give up the pizza and go back to sleep. So that's that loop, right? You're in a loop. You try to grab one thing followed by the other. If you try to grab the pizza, if the bell goes off, you wake up, you run over to the pickup counter, try to grab the pizza, someone already beat you to it, you go back to sleep. So that's, again, motivating why you have a loop, because everybody's waking up, they're all trying to get the resource, but they can't all get the resource at the same time. So you need a pizza, you need the keys, you need the truck. Well, the truck and the keys kind of go hand in hand. So that's basically a way to think about this. And if you think through the analogy, you'll see that it's actually a pretty good analogy for this. It also would indicate the use of signal all versus signal, because you're ringing that bell and it's waking everybody up. If you did signal, then only one person would wake up, which might be more efficient, but it doesn't make our analogy as good.